the next panel that we have is something that I put together on the following assumption, okay? That everybody seems to be, right now, as US pivots away from China and does more and more investing and partnering with India, everybody's building the little engines that, that will fly on the road, which will sort of fly on the road in between India and US. But are people investing in the road infrastructure itself? And for that, by that I mean, are people investing in the chip industry, the hardware on which a lot of this new AI revolution is going to happen? For that, I have brought together a panel that consists of just the star people that I know, which includes my very dear friend, Dipender Saluja from Capricorn Ventures. He manages about 10 billion in assets for investors who strive for extraordinary investment results by leveraging market forces to accelerate large-scale impact. Ashu, if he has the stomach, will be again on the panel. Everybody knows Ashu Garg of Foundation Capital. Rajeev Madhavan is the co-founder and partner of Clara, where he focuses on early-stage technology investments. Rajeev brings operational skills from founding, building, and running as CEO, 2 highly successful companies. He has been a venture investor in over 35 companies. Rajeev also a recipient of the Red Herring Top Innovator Award, the Lifetime Achievement Award at NITK in India. And then there is Rubin. Has 20 years of experience in technology and financial services. Ari was previously, currently at Celesta Capital. Ari was previously a senior director of corporate development at Qualcomm, where he focused on partnerships, and as vice president of investment banking at JP Morgan and associate director at UBS. Ari was an electrical engineer at Raytheon Space and Airborne. So that's Rajeev's Ari's very secret past. I didn't know that, Ari, that you had deep roots in the military industrial complex. I think we need to dig you for more information on that. But I'm going to let Dipender Saluja run with it from here and tell us more about what is this $1 trillion chips bill and what's happening there, what impact it's going to have in this whole US-India corridor. Thank you.
Thank you, Asha. Is this on? Okay. Thank you, Asha, for those kind introductions. I'm glad you were able to introduce everybody. And Ashu, since you were on earlier, you don't need an introduction right now. So it's a pleasure to be here with the co-panelists. Believe it or not, completely coincidence, because I didn't pick the panel. 3 of us actually worked at the same company 20, 30 years ago. I guess 33 years ago for the 2 of us. And so I don't know if you intended it that way, but there's at least 3 out of 4, and I'm sure we'll get to know the 4th one, who were pretty heavily involved in the business of chips and semiconductors. And as we were talking about this over the last couple of days, one of the common conclusions was this is a topic that has not been discussed at conferences like TiEcon recently, because for the last 20-some years, this was sort of a lost topic. And I think that's a metaphor for pretty much the space around the world. And so in some ways, we could have labeled this talk something like bringing the silicon back in Silicon Valley, because when I moved here 35 years ago, the early TiEcon and SEPA conferences used to be almost entirely about semiconductors and electronics and hardware. And of course, the 3 waves of innovation that followed that led to this becoming less of an issue. And we are seeing a resurgence. So this talk is quite timely. And I think to some extent, that resurgence has that exclamation point put in over the last year because of things like the CHIP Act that Asha referred to. And for those of you who don't know or may not have had a chance to hear about it, the CHIPS Act was a bipartisan bill that was passed last year with the US declaring that they wanted to get back into the chip business and wanted to incentivize the development of the semiconductor industry across the value and supply chain and passed a $55 billion incentive package, which is to be deployed in the next 5 years into various segments of the chip industry. And then on top of that, those federal programs, there were several state-wide programs. You may have heard of the large $100 billion investment announcement from Micron, for example, in upstate New York, which comes with a bunch of things from New York, and others to follow. There was a big program from Arizona for TSMC, and you'll start hearing more and more of that coming. The amazing thing is that this has set off a bit of a global race, because just a few weeks ago, Europe announced their own CHIPS Act in response to that, and that is $47 billion, which for the EU, I would say, is pretty unprecedented and quite large. And it's the kind of reaction that you want if you're in the industry, is for all regions to wake up and say, we're all going to get behind this really important piece of the electronics ecosystem. And then India earlier, and I'll ask Rajeev to talk about it in a few minutes, announced a $10 billion roughly program, which while seems like a smaller number compared to Europe and the US, many of us know that this is something that has been talked about for literally decades, and so it has been quite a nice surprise to see something like that come about, and hopefully it's the beginnings of many things. So with that, I'll switch to a few topics here, and I'll just put together a quick framework that we discussed, that really the importance of chips, other than the fact that chips are the basis of almost all the electronic devices around us. I mean, we've grown up knowing that computers were powered by them, and then phones, and then lots of consumer electronics. But the entire data center infrastructure, the entire computing infrastructure, recently you heard about people up here talking about space infrastructure. And then the one that became sort of popularly known over COVID was the automotive industry, and how much that has now become dependent and reliant on the semiconductor and chip industry. I'm sure those of us who were in EDA or chips 20, 30 years ago, we all had our versions of slides that talked about, in the future, cars will be fueled by chips. And people used to look at us and say, I don't know what you're talking about. And I think at this point, a very large percentage of a traditional car's content is chips, and soon to be in the future, 60–70% of a car's value is going to be in the powertrain and the batteries, which are again going to bring a whole lot of chips to come along with them. And then the last point, which picks up on the points made in the prior panel, is the excitement around AI. While what we are seeing today is sort of that tip of the iceberg around AI being these cool software and online models, what's really going to determine the winners in AI is going to be the computing infrastructure and the communications infrastructure. And that's where the global interest is rising, because there is a general acceptance now that the countries, the regions, the nations that win or achieve AI supremacy will have unprecedented economic and political power for the coming decades, sort of like what the Industrial Revolution did a couple of hundred years ago. And so what you're seeing is a shift in the mentality for those of us who've been around for the last few decades in this industry, from saying, you know, this is a completely free market, let things flow to where the cheapest cost is, we'll all benefit from it because we'll all get really better, cheaper, faster components to build all our cool ideas, to a shift where nations and communities are saying, that's all fine, but I don't want to lose AI supremacy, because this isn't going to be about I can buy it from one place and move it to another or arbitrage it. This is really something I need to have access to and have control to, not just the supply chain scares that we got in COVID, but for many, many strategic reasons. And in these types of industries, vertically integrated industries have generally succeeded. So hopefully that gives you a little bit of an idea as to why this topic is topical and why it's important. And with that, I'll turn to a few questions and maybe start with Rajeev on my left. Rajeev, you've been investing in the semiconductor business for a long time. You obviously started two very important companies, Ambit and Magma, which were at the sort of high point of that disaggregation of the semiconductor supply chain. What do you think is fueling this excitement in chips right now?
Maybe I should take that mic.
Sorry.
So I think, we are at a very interesting intersection on this CHIPS Act. Ultimately, the question on when it applies to US-India corridor, at 100,000 feet message, everything about this sounds great because India is focused on 10 billion at 40 nanometer, 28 nanometer. If you look at everything in this electronic or all the electronic things I see here, everything is 48 nanometer, 28 nanometer. If you look at data center and the high-end AI chips that you mentioned, they are all 2 nanometers, 3, right now 3, but trying for 2, et cetera, et cetera, et cetera. So from a holistic message perspective, the two democracies could make a massive contribution at the low end of the chips all the way to the very high end of the chips. Now whether that'll happen because of not just geopolitical but execution things, it's a challenge to make that happen, right? I mean, the whole goal should not be about we are going to just make it an anti-China or an anti, just a competitive philosophy against China. It should be about how do we actually stay ahead in terms of the process technologies that comes about. With Moore's law being seriously limited, et cetera, can you do some things that contribute to that? That I'm not sure the CHIPS Act will do. I think we have an opportunity of creating employment in doing IP in India, employment in India for 28 nanometer, 40 nanometer design. These are technologies that can be done today. Whether we succeed here is a question of, Intel did not succeed for lack of money in terms of building an Intel Foundry Services. It's a question of the culture that TSMC had versus Intel had. So we have a long way to go to make the CHIPS Act, especially on the high end of the process nodes, work well. On the low end, there's beautiful opportunity for India to make contribution to the vast majority of chips that's going to be done in 28 nanometer and 40 nanometer kind of technologies. So lots of good things are possible with this act and with this amount of money. For example, in India, there was a call right after they okayed the money to get IP built out. They expected or want to pick 20 companies to build certain IP. They got 4,000 proposals. So this is India. So the vast opportunity that it provides is fantastic. It's good because you're going to get a rise in talent and a rise in opportunity for everyone. So we are at a cusp. This is going to be something that will increase that. What the execution is, because any Uncle Sam or any government program, the success is questionable in some of what will end up happening.
Thank you, Rajeev. By the way, just to add to what Rajeev was saying, and he could tell you lots more about it as well, is one of the hidden secrets that happened in the Indian ecosystem over the last few decades was that companies like Cadence and TI and ST and many others started setting up large design centers there, and they were going hand in hand with a lot of the software service providers like Wipro and others who were building these build-to-own design centers. And those design centers have kind of been islands within the Indian ecosystem in that they physically exist in India, but they're completely connected to products that are being developed in the US and Europe. And so there has never really been a big proliferation of that talent into a local ecosystem because they've all been sort of remote pre-Zoom work teams that work like that. But that's really an interesting setup for that opportunity because you literally have pools of thousands of engineers who are design literate and software literate.
Look at the pool of entrepreneurs.
Yes.
It's such a fantastic pool that exists in India in semiconductor aspect of things, right?
And they've literally grown up with American and European companies sort of in coordination. So maybe that's a good transition to you, Ashu, given even though you're a veteran of Cadence Design Systems, you spent a whopping 1.5 years there. And I remember you from then. and by the way, Credence I think is a great place to be from. You've been focused largely on software, and obviously recently AI, and I talked a little bit about AI driving this. Tell us, what do you think the opportunities are? And I think this is a metaphor not just for India, but pretty much most entrepreneurs in the audience who come from the software world, thinking about what does this mean for them and how can they participate in this chip fiesta?
So, over the last 30, 40 years, while silicon has always been important, it's the bedrock for all technology innovation, most software developers or founders have never really had to think about what is going on at the silicon level. Most societies have never really had to engage with the risks associated with being part of the club or out of the club at the silicon level. You just sort of take it for granted. And which is why for the last 20 years, silicon has sort of been in the backwaters in many ways. What has changed with machine learning and AI is silicon has once again become the constraint. In many ways, as was true in the 70s and 80s, that the extreme of what's possible is a function of what the silicon can do. You also don't have the standardized operating systems that we've had in software, and so the abstractions have changed. And so as a result, every engineering team that is pushing the limits of software in the world of AI is having to think about silicon. I'm on the board of a company I'm an investor in a company called Anyscale, and their core innovation is how do we gang up hundreds or thousands of GPUs, and how do you orchestrate GPUs to enable software engineers who are writing code in Python to actually to be able to drive execution. You never had to think about that problem in most other realms of software. So I do think silicon is the new oil. I do think software engineering teams that are pushing the limits of machine learning, I think we increasingly think about the silicon dimension. I do think it's a huge opportunity, as we've talked about for India. We have the software talent, we have the demand in India. India is now one of the largest buyers of silicon in the world, and probably is on a short list of 6 or 7 countries that can build a silicon industry. I think that list is less than 10. And everyone else, I think, will be relegated to being a buyer from someone else. But it's early days. I think this movie will play out over the coming decade.
So great points. That prompts me to talk about 2 things here. One is, it's interesting you said that software developers have not had to think a lot about it. I don't know if there have been other topics at the conference yet around this, but when you think about the debate around what is generational AI going to take away or replace, one of the things we talked about last night was it is likely going to take away the generic software developer tasks, which were the realm of a lot of the large services companies over the years. And so if you think about it, if you're in that mode of saying, what next? If generic software code developing is going to be relegated to AI, the kinds of things that Ashu is just talking about, which is that interplay of software and chips and hardware and IP, which Rajeev alluded to earlier, is where the value add is going to come. And if we are to believe the AI visionaries that the goal here with AI is to make every person a superhuman, what you're going to see is the opportunity to make engineers who used to only do software, or engineers who used to only do something else, become super engineers to be able to do that crosswork with the tools that we are getting. Ari, I don't know if that's a good tee up for you, given you have been investing at Qualcomm, who I know have thought about a lot about this, and then more recently at Celesta, across the spectrum.
Yeah. I mean, for us at Celesta, we're about $1 billion deep tech fund, and we're very focused in investing in deep tech in these areas that are not going to be easily disrupted. And we've been investing in India for about 10 years. And so the 3 areas that we are investing in India is number 1, deep tech, number 2, industry transforming companies, and 3, bioconvergence. And first of all, deep tech, India is really coming at it from the ground floor. If you look at the largest industries in the world, semiconductors, jets, precision parts, and branded pharma, India currently has about a 0% share. And right now, the political will is definitely there. You mentioned some of the funding that's happening. And so that's why we're betting in investing in new fabless companies where there are going to be national champions, because there's such an interest to have indigenous champions emerge. And so we really like this area.
Great. So Rajeev, coming back to you for a second, when we were all building the EDA industry, what became obvious was there's frameworks and large problems to be solved, whether it's synthesis or place and route. But there's a lot that goes into the building blocks, the IP, everything in between. As this chip journey moves forward, what do you think the opportunities are to go after?
So for the first time, I'm actually seeing, you alluded to a point of using generative AI for writing software, generic software. The same thing will happen for a lot of generic chip design.
Yeah.
There will be generative AI generated designs, and there are a bunch of startups that have pitched to us that I've essentially seen. And these are very, what I call premature, because they are not people with expertise on what's required at a 2 nanometer designing this, but we will get there. So the wonderful thing about this whole thing is people are going to begin to have to eat your own dog food, right? You're building the generative AI on AI chips, and we're going to have
AI will build AI.
Build AI chips. And that'll happen especially for the inference, for the low-end things of the chip design. That will end up being a good solution, which is going to be very interesting to watch. And it's a good opportunity, especially in a place like India, because we have the capability of designers who can do that low-end inference chips for cameras, inference chips for this, etc. Design that with an AI system. It will end up happening in the next 10 years. So the whole space is up for change. Domination of this area will require not designing it like the past, designing it like the future, and taking the risk of doing that, right? But in terms of the fabs, the costly fabs are something that's very, very difficult for entrepreneurs to take over and do. It's easier to do the design aspects of things.
Absolutely. That's a really important point, because most people just assume fabs are the domain of people who can spend $50 billion, so clearly not for anybody in the room. So, Ari, for the entrepreneurs in the room, what would you recommend that entrepreneurs think about as the next big opportunities in the space that they can pursue and go after?
So, we talk about ChatGPT. This is going to create a tremendous requirements from a compute perspective. That frankly, for the scale of India, is just going to be so expensive to afford. And so, new fabless champion companies doing AI acceleration, across the data center, even in sensor fusion for vehicles, they're going to need to emerge in order to just handle the bandwidth required by such a massive population. And these companies, they're going to need to think about the Indian economics in mind. Indian individuals make $2,000 a year per capita. And so these are going to be new companies that have to come up to scale with new economic structures and models, and then they'll be able to transport and export these knowledge and the IP to other parts of the emerging world. And so I think these are really important areas to be investing in. And additionally, also going up the stack. I mean, India is going to be a large consumer of aerospace, a large consumer of electric vehicles. And all of these things are going to have to be built and manufactured. We have a very exciting portfolio company in the aerospace area, Idea Forge, that actually emerged in the last couple of years during the flashpoints between India and China and Ladakh. It's a drone company that does security and surveillance. And now we're actually about to invest in a new company that is building rockets. I think the name was mentioned soon. And so, across the board in these manufacturing related industries, not in not in traditional manufacturing, which is assembly lines. People tout that 1/10 of iPhones are built in India, but these are really just assembly lines. I'm talking about advanced manufacturing, and not just in fabs, because that is the playground of the very, very rich. But there is capital that's going even to that, but across all of these areas.
Ashu and Rajeev, any advice for the entrepreneurs in the
I think the thing I
audience?
would add to what Ari said is, the silicon value chain, both upstream and downstream, is massive. And so while, hopefully over time there will be a handful of fabs, and it's unlikely that anyone in the room is going to be building one of those sort of out of their pocketbook, I do think the existence of fabs in India will create hundreds, if not tens of thousands of upstream and downstream opportunities, whether it's in packaging, it's in supply chain, it's in logistics, it's in building components, it's in services and maintenance. And so I think those are the opportunities. And those businesses are well understood. They're well understood in China, they're well understood in Taiwan, in Japan, in Korea, and once upon a time in the US. And so I think that's the opportunity for entrepreneurs in India, is to take those businesses and those business models and transplant them to India as the fabs get built out.
Great.
See, I think our India's expertise in metallurgy, et cetera, is very good. So it may not be the 28 nanometer or it may not be the 2 nanometer technology, et cetera. I have 2 companies that I've funded we have 3 semi out of 30 companies. The 2 companies we have, one of them has a gallium nitride fab of their own. The total cost is around $2 million to build that fab. But they provide an organic LED-based interconnect technology. The other one is a fan in places where you cannot put a fan, 0.15 millimeter thickness material on which you can etch the piezoelectric material and you can take the heat away as like a fan. The technology cost to build a fab is about $2 million. So things can be done if you think of with an innovation and metallurgical background, given that India has it. Both companies are founded by people of Indian origin here, but I'm sure it can also happen in India over time.
Great, thank you. I'm getting the signs that we have to wrap up. I guess we had to cut a little bit of the time out of this, but maybe I'll just translate for the audience, because this is an issue that keeps coming over and over again. Software companies, cheaper to build; hardware companies, more expensive to build. The examples that you just gave, if I compare it to the $1 billion every 6 months that Uber had to spend to attract rides, you could build a lot of fabs for that.
That's right.
Okay. On that note, thank you to all, and thank you for joining us for this session, and hopefully we will talk about this more next year.
Thank you.
Thanks.
Thank you so much.